When we look now, again in the tent with PSA, but using bees, live bees inside a cage, the PSA survived until day 6. So 6 days after we had put the contaminated bees inside this hive, we could still find bacteria. Now it's very low levels. It averaged out to 6 individual bacteria per bee, so that's just right on the limit of detection. And it's 0.02% of the original inoculation level. So again, the good news is that it drops off dramatically very quickly, but you can find bacteria 6 days later. Now the point about this is that we're talking about a very artificial environment. The temperature is elevated, and in actual fact there was many days when the temperature was well above 30 degrees. And so if temperature does slow down PSA or affect PSA, then potentially this is not showing us the full story. So now we turn to the results using PSS in the field. So in the field using PSS, now looking again at discs, this shows quite a different story. So this bacteria, on the blue line here, represents the discs that were on the outer edge of the hive. And that we can see here, right out to day 14, we were still recovering bacteria. So 2 weeks later, we were still finding this bacteria in the hive. So inside the brood, where the temperature is about 35 degrees, we are getting, the last day of sampling was day 9. We didn't find anything on day 14. But there's still, 13,000 colonies per disc, whatever that means in terms of infection, and 0.03% of the original inoculum. But for the outer edge of the hive, we're still getting 430,000 individual colony-forming units per disc on those outer edges on plastic discs. So, all right. Now, ignore the 2 there. So when we're looking at the caged bees now, so again, PSS in the field using caged bees, just like in the tent, we see this initial fast drop-off within 24 hours. And inside the brood, where the temperatures are higher, by day 2 was the last day that we saw PSS, and after that we didn't find it. But again, day 6 pops up here as being the last day that we found PSS on bees on the outer edge of the hive. And I think what this shows you is that bees are very good at cleaning themselves of bacteria, and you may find very low levels very quickly with bees, whereas with the discs, it's a good clean environment where the bacteria can survive. So the second question we're asking is whether they can be spread within a hive. And this is really interesting because this is talking about our control discs in these hives in the field. So these discs started out with nothing on them, no bacteria growing on them. And in the first 24 hours, we started to detect PSS. And by day 2, one disc had 11,000 colony-forming units on it. And so there's this initial period of time when the bacteria is being spread within the hive, and these discs are protected inside a little plastic cage, so they do not come into direct contact with the bees. So the material that is contaminated in the hive has been spread to other surfaces. And this story continues with bees as well. So this is the experiment where we put marked bees that had been coated in pollen into the hive, and they had very high levels of contamination on the first day. But out here on day 9, we were still recovering some bacteria from these bees. But that is, I think that's largely because of the very high levels of contamination. But when we take away, if we just take away these day 0 points to look a little bit more closely at what's happening on day 1 and 2, we can see here on day 1 and day 2, we're getting readings of bacteria from some of these bees that were not marked. And the important thing about this is that there could be 60,000 bees or more inside these hives. We've taken 100 out and contaminated them. And then every day we go back and we take 5 marked bees that we know had contact with the bacteria, and we're taking 5 bees out of 60,000 that we didn't have direct contact. And we're getting quite a few of those returning a positive signal for this disease. And the peak there was 3,000 or so per bee, sorry. So just briefly in summary, what we've shown in terms of survival in hives It's not really clear-cut, but we can say that there was this initial dramatic reduction. Less than 0.5% remained on bees after that initial 24-hour period. But there was quite a period of time that we could still recover bacteria, both PSS and PSA. But by 9 days, neither of those bacteria were recovered from bees that were inside the cages. By 6 days, we couldn't find PSA on plastic discs, and after 14 days, PSS was still detectable on plastic discs. So I'm not too sure why there's such a difference there between PSA and PSS, but I think the take-home message for this is that these bacteria, neither of them are specific to bees, they're plant disease-causing bacteria, and these bacteria are actually surviving inside the beehive environment. The other point is that both these bacteria survived longer on the outer edges of the hive, where the temperatures were more closely related to the ambient temperatures. In terms of spread within the hive, bacteria were spread very quickly within the hive for a period of up to 9 days. And some of the bees that were initially contaminated with that pollen still showed bacteria more than 9 days later. So what does this also mean in terms of the management of PSA? Just some of the points here that after 24 hours, as I said, very little remains. But this is an experiment where we inoculated the hives once. There was only one occasion when the PSA or the PSS was introduced to the hive. In an actual orchard environment, you're going to get, in a day, many bees potentially bringing contaminated material in, and then many days when bees could be bringing contaminated material in. So although our initial inoculations are very high, I think potentially we need to think about that cumulative effect of bees bringing in contaminated material into hives. And that bacteria could potentially last in the hives for periods up to 2 weeks. Now, obviously, they were growing on little clean plastic discs, and we need to find out how well does PSA survive on actual hive structures. Another very important point here is that bacteria is very quickly spread throughout the hive. So that if a group of pollen foragers is foraging in one contaminated orchard, they're quickly spreading it to bees that could be foraging in an uninfected orchard. So there's really here, I don't think there's much benefit in restricting the movement of hives within a zone. Even if you're sure that your hive has not been on an infected orchard, there could be bees in the area that are visiting an infected orchard. And there does seem to be some support for the idea of a stand-down period of 6 to 9 days that would lead to substantial reductions in PSA. So based on this research, these are the recommendations that KVH has come up with for managing bees and PSA. So these are KVH's recommendations, and if you have questions about them, do direct them to Neil or someone afterwards. So the KVH's recommendations are that hives used within a priority zone should not be used again in any orchard outside a priority zone. So any hives leaving a priority zone should be removed to an area that is at least 5 kilometers from an orchard to minimize the risk of the bees taking the material. Hives that are placed within a priority zone may be used again within the same priority zone as long as there's adherence to the orchard hygiene protocols. Hives placed in an orchard outside a priority zone may be used again with adherence to orchard hygiene protocols. And there's also a proposed 6-day stand-down period that may be applied to hives moving between regions, and recommendations on this will be made as soon as possible. Right, thank you.